In this video, you will recall how to graph and solve a linear inequality in two variables. Let's look at your packet and work through the first couple of pages together. For this first example, we have y is less than 2x plus 2. Notice that this is already in slope-intercept form. So we're going to start by graphing the associated line. We're going to be careful to pay attention to what the inequality is here so that we know whether to make this a dashed or a solid line. For strictly less than or greater than, you should use a dashed line. This indicates that the solution does not include points on that line. And if you recall, we shade above or below the line depending on the problem. So let's take a look. We're first going to start at the y-intercept, which is positive 2. Put a point there on the y-axis, and then we look at our slope. And slope here is 2, or 2 over 1. For some of you, it's helpful to go ahead and write what slope and y-intercept are. Remember, y equals mx plus b. M is 2, or 2 over 1, and b is 2. All right, so here's our y-intercept. Now we're going to use our slope to count rise over run from the point we already have. So up 2, right 1. And we can do that a few times so that we get a good line. Because it's strictly less than, we're not going to include the points on this line. So we're going to use a dashed line to indicate this inequality. Notice that I've extended the line to cover the whole graph. This is important because with inequalities, we're going to shade the region of the graph that explains all of the solutions to that inequality, so that every point in the shaded area would be a solution to this inequality. We do this by picking a test point, and the easiest one to pick is usually the point 0, 0. So let's go ahead and pick the point 0, 0 and plug it in to the original inequality. If you plug it in and it's true, it works, then you shade that side of the line. If it's not true, you shade the other side. So y is 0. We want to know if this is true. X is 0. And when we work this out, we get 0 is less than 0 plus 2 is just 2. Well, 0 is less than 2, which means we're going to shade this side of the line. And there we go. The other thing you might recall from graphing inequalities in the past is that less than will shade below the line and greater than will shade above the line. But you can always pick a test point to know for sure, because sometimes that's not so clear. Let's take a look and fill in some of the notes that are on this page. We used a dotted or dashed line to show that the inequality is less than or greater than. This indicates that the line does not contain any solutions. So points on this line will not work in the inequality. They are not solutions to that inequality. I want you to go ahead and try this one on your own. Be careful to first put this in slope-intercept form. Pause the video now and give it a try. So, how did you do? The first thing you should do is put this in slope-intercept form, which I've done here. Make sure to identify m and b. Don't forget m can be a fraction. It's actually more convenient as a fraction because then we have rise over run. Also, this is a solid line because there's an equal to under the symbol. So greater than or equal to or less than or equal to will include the points on the line. And that's important, so we use a solid line to indicate that. I used my test point of 0, 0 again. The only time you wouldn't want to use that as a test point is if that point is on your line. So then you can pick any other point on either side of the line. If it works, shade that side. If it doesn't, shade the other side. Again, notice from slope-intercept form, and this is important, that since it's greater than, the shading did happen above the line. Again, to complete the notes, we use a solid line to show that the inequality is less than or equal to or greater than or equal to. This indicates that the line does contain infinite solutions. I'd like to get you started on one more example, and I'm using this one on purpose because something important is going to happen that I feel like a lot of students forget. Go ahead and pause the video and just put this in slope-intercept form. Don't graph it yet. Let's check how you've done when you come back. So I wonder if this caught you, if you remember that when we're solving inequalities, if we divide or multiply by a negative number, we have to change the direction of the inequality symbol. We do everything else the same, but in the step where you're dividing something away, if it's negative, change the direction of the inequality symbol, which is going to change our answer dramatically because the shading is going to end up on the other side of the line. Go ahead and pause again and do the graph for this inequality. So how'd your graph go? I hope that you identified your slope and your y-intercept and that you remembered that since this was strictly greater than, we did a dashed or dotted line, and because it's greater than, we shaded above. Now, if you had done a test point, if you'd made a mistake and left this as less than, you should catch your mistake, because if you plug 0, 0 into the original inequality, you'll see that you get 0 is less than negative 12, which is not true. 0 is bigger than negative 12, which means you're going to shade the other side of the line. So you can see how the test point can help you to check your work. A little extra information here to help you complete your notes. The standard form for a linear inequality is just a modification of y equals mx plus b. You can use any of the 4 inequality symbols as shown here. The dotted or solid line, that's called a boundary line, and that's an important word for you to recognize as we move on to linear programming. To determine which side of the line to shade, we choose a test point. If the test point satisfies the inequality, meaning it's true, we shade the side that contains the test point. If the test point doesn't satisfy the inequality, if you get something that's not true, shade the other side. In the next videos, you'll learn how to write a system of inequalities for a given graph, and you'll identify solutions to that system. You'll learn to graph to solve a system of 2 or more inequalities. And finally, we'll solve word problems by creating a system of inequalities, graphing them, and then interpreting the results.